to make sure you can hear me right. سامعيني؟
أيوة دكتور.
Okay, great. Okay, so remember on Tuesday we are going to have our mock test on our test assessment 1. It will be inshallah during the class time at 10 o'clock. I have already uploaded for you a mock test to show you how the exams and how you have to fill the answers. So you need to be familiar with that. It's already on SULMS. So today we are going to finish our last part of week number 6, in which we are going to start talking about registers and cache. Okay, in the last week we talked about ALU and arithmetic logic unit, and we understood the design of the ALU in full details. So during this class we are going to talk about cache and registers. Now when it comes to cache and registers, I think all of you know by now about registers. Registers are what are registers? Why do we need registers?
Storage element.
Storage element, good. But where is it located?
Inside the CPU.
Inside the CPU. Okay, a storage element located inside the CPU. Now, anyone knows about cache? Anyone heard about cache? Cache memory is basically a memory that is between the CPU and the RAM. If you check your computer and you go for the task manager, we are going to go to performance and we are going to read the following. Inside performance over here. Okay, let me share my screen. Yes. I will share my screen. Okay. So inside the cache over here, you see we have L1 cache, L2 cache, and L3 cache. This is for my CPU on my laptop. So I have 3 levels of cache: level 1, level 2, and level 3. Level 1 is 256, level 2 is 1 megabyte, and level 3 is 6 megabytes. So we have 3 different levels of cache inside a computer system, inside this processor that I am using over here. The idea is the cache is faster than RAM, slower than registers. So today we are going to talk about the registers and the cache memory. So we are going to talk about registers and cache memory. So this is the memory hierarchy. This is what we call the memory hierarchy. The memory hierarchy, on top sits the CPU registers. Of course, what we are talking about, as we go up higher, we increase the performance and increase the cost. Increase the performance and increase the cost. يعني the CPU registers are the most expensive and the highest performance. Highest performance in terms of what? In terms of speed. سرعتهم, they should be as fast as the CPU, if not faster. They should be as fast as the CPU frequency, if not faster. So they are very fast and their performance is very high. They're expensive. They are also expensive. Okay. Then after that we have the cache memory. It may be level 1 and level 2, and like you saw in my computer, we have level 3 also. Then we will talk about RAM and ROM, or RAM in general. Then we have the storage types, such as ROM, which is stores BIOS for the computer, removable drives, network and internet storage, hard drives, and so on. Then we have the input sources. طيب, What our plan is what? We will start talking today about registers and cache in this week, okay? Then we will talk about RAM and how to design a RAM during week number 8, and week number 9, I think we will talk about ROM. So we will cover all the components of the memory. But what I need you to know is registers sit on top of the memory hierarchy because they are fast, and they are as fast as the CPU. After that comes the cache, and we will talk about why we have cache and not. Nowadays we have something called Optane memory. Optane. The Optane memory, I will be talking about it. It is between the cache and the RAM. Okay, so between the register, the CPU, and the RAM, we have cache. Now we have something called Optane, and I will talk about it later on and explain to you. Now, the methods of accessing memory. Different types of methods, such as sequential. Start at the beginning, read through in order. Access time depends on the location of the data. Example, the tape. What do we mean by sequential? When we say sequential memory, what do we mean by sequential memory? متتالي. طيب example التيب. What do you mean by التيب؟ متذكرين شريط الكاسيت؟ مسجل للسيارة؟ ولا انتوا جماعة الفلاش على طول؟
لا لحقنا.
لحقتوا له. طيب التيب is a sequential memory. ليش sequential؟ لأنه if you want to read the last song on the tape, you have to go through all the songs. صح؟ متذكرين؟ So you need to pass through. هلا الأيام هاي you want to go to the next song, you just press on the song and it will start. Sequential means we need to go through all the data in order to read one location. Sequential بالدور بالترتيب. Okay, you cannot jump in the memory. Then you have the direct. Direct individual blocks have unique addresses. Access is by jumping to vicinity plus sequential search. Access time depends on the location of the previous location. طيب. Direct access, such as the floppy disk. Anyone, you know the floppy disk? Also, I think you know the floppy disk, صح?
Yes.
Okay. The floppy disk, inside it is simply a disk. And this disk you can access by going through the information direct. Example, a disk. Now, inside your computer, when I ask you what is the size of your hard disk, okay, your hard disk. Now, if I can show you here, let me show you how a hard disk. Okay. Video. And I think this one is okay. Now, in a disk, in a computer system, okay, in a computer system, okay, so in a computer system, what happens is you have disks. داخل الهارد درايف اللي عندكم. You have these disks. You see these disks? Now, once your computer start working, the power up, this disk will start spinning, and the needle will start to move inside the disk. See? It moves very fast. So when you read data, okay, when you read, see, this is deleting folder. See how it deletes a folder? It removes the data inside the folder. So when you read data, it depends on the location of the needle and where the data is located. طبعا هو مش, it's not one disk. It's actually multiple of disks on top of each other, and the head is moving all around. This is copy and paste operation inside your hard drive. Now this is the sound you hear sometimes inside your computer. When it is when everything is silent, you can hear a sound. It's basically the hard drive. This hard drive, as you can see, it is very fast. Now the problem happens if you drop your hard drive and the needle is moving around, you will damage the disk. This is a quick format. See, this is a quick format, how you format your computer. Okay, so this is basically a quick format. It moved very fast. Now, how you power it down? Once you power down, it will go and park. It has a parking gear over here, and this one will stop. Now, this is basically the hard drive, and this is why your hard drive is what of type direct memory access. Individual blocks have unique addresses. Accessing is by jumping. Okay, accessing time depends on the location of the previous location. Then we have random. Okay, then we have random. In random, individual addresses identified locations exactly. Each time is independent of the location of the previous. And random, like RAM, you give the address, you get the information. You give the address, you give the information. Now, example is the RAM. Other examples is your flash memory. Other examples are your SSD, your solid state drive. All of these are basically random, but initially the name was given to random access memory was given to RAM, so it sticked with it. بس يعني الصحيح انه your flash is a random access memory, your SSD is a random access memory. Random means you can access any information at any time. بس اعطي address, you get the information. Indirect, yes, you have address of the block, but you need to have physical jumping. Or physical movement means more time wastage. More time wastage means that it will consume more power. Sequential, you access the memory one block at a time. Then we have the associative. Associative, you go to a memory location based on an address plus some value. So data is located by comparison with contents of a proportion stored. Access time is independent of the location of the previous access. But associative memory type is a little bit different than random because you need to have the memory location associated with another value. Okay, we will pass through associative memory in cache, and we will pass it inside the next year, inshallah, in microprocessors and microcontrollers when we talk about addressing mode inside the computer system. But during this week, we are going to be talking about cache, and we will talk how cache is operating. Now, again, the hierarchy list starts with registers. Then we have L1 cache, L2 cache. Then we have the main memory, اللي هي بين قوسين the RAM. Then we have the disk cache. Then we have the disk. Then we have the optical, and then we have the tape. طبعا, as you go up, it becomes faster. Okay, as you go up, it becomes faster. You know what is an optical?
اللي هو CD drive.
Yes, CD drive with DVD, even the Blu-ray are all called optical memories. So, the part one, we are going to talk about registers. They sit on the top of the hierarchy. بين قوسين, they are the fastest. Match the speed of the CPU. Large and consume significant power. Large and consume significant power. This means we cannot have a large number. Since they are large and they consume a lot of power, you cannot have a lot of registers inside your computer. The number of registers in a processor are small. Small. كم يعني small؟ 2 3 how many? Anyone have any ideas? جربوا أرقام.
دكتور ما هو اللي 32 بت و 64 بت؟
هذا السايز تبع الريجستر. هذا حجمه مش عدده. عرفت؟ الريجسترز عادة 32 ريجستر تقريبا. 32 registers. فهذول 32 registers, okay, these 32 registers are basically the ones that are inside your computer. Now, they are small permanent storage locations. Small permanent, مش small بالحجم. الحجم large. okay, بس small تخزين سعة التخزين تبعتهم قليلة. كم يعني؟ زي ما حكى زميلكم maybe 32 bits أو 64 bits. يعني كل register can hold only 64 or 32 bits. فهم small permanent storage locations within the CPU used for a particular purpose. Each register has its own different purpose. Each register has its own different purpose. They are manipulated directly by the control unit. ايش يعني manipulated؟ متغير متحكم. بإمكاننا change its value. The only thing that can change their values is basically the control unit. Some of them are wired for a specific function. Some of them are wired for ايش يعني wired؟ يعني موصل مبني موجود for one specific function. The size is in bits or bytes زي ما حكينا هون 32 bits أو 4 bytes 64 bits أو 6 bytes أو sorry 8 bytes not in megabytes like memory not in megabytes can hold data address or instruction. The use of registers. They are a scratch pad for currently executed programs. Now, a scratch pad, paper, small paper, you keep it with you. When you want to do the calculations, you do it on a scratch pad and then you throw it away. When you want to do an operation, you have to have your values stored in the register. مثلا بدي أجمع قيمة A plus B وأحطها في C. بروح بقرأ من الميموري الكونتنتس تبعت A بحطها في ريجستر. بقرأ من الميموري الكونتنتس تبعت B بحطها في ريجستر. بجمع الفاليوز تبعون التو ريجسترز وبخزن الاوتبوت في الميموري. This is one operation. طبعا it's not like that all the time you read from memory. Some of the time you have your registers with you and other times you have the information already there in the cache memory. Stores information about the status of the CPU and currently executed programs. مثلا في عندنا ريجستر بيحفظ الادرس of the next instruction to be executed اللي بنسميه احنا الانستركشن كاونتر او بروجرام كاونتر. هذا ايش شغلته؟ يحكي لك which instruction to execute next. ايش الادرس تبع next instruction to be executed. Some of them read the signals from external devices اللي هم الفلاج registers. فعندنا different registers and each register will have a different task inside the computer system. Now, register types in general. في عندنا نوعين general purpose registers وفي عندنا special purpose registers. Now, the general purpose registers they are user visible. يعني أنا بإمكاني أكتب برنامج على الأسمبلي language وأحكي move لل AX 51. The AX is a general purpose register. This is we are going to talk about next year, inshallah, in microprocessors and microcontrollers. But we have a general purpose register which I can use. They hold intermediate results of data values and loop counters, equivalent to the LMC's calculator. Typical several dozens in the current CPU. Several dozens يعني عددهم dozen 12, several maybe 24 or 63 and so on. بعدين عندنا special purpose registers. Special purpose registers كل register له نوع أو كل register له هدف. So we have different types of registers. Registers هم the program counter, also called the instruction pointer. هذا program counter, it points to the next instruction to be executed. بعدين عندنا instruction register, it stores the current instructions that we are executing. فشوفوا احنا بنروح بنجيب الانستركشن، مش عندنا حكينا fetch decode execute. بنعمل لما نجيب الفetch instruction، عشان نجيب الانستركشن بنقرا البروجرام كاونتر، لانه البروجرام كاونتر will tell us from where to bring the instruction. Once you bring the instruction, you store it into the instruction register. We have the memory address register. The memory address register, it holds the address where we want to, or it is the connection between the CPU and the address bus. The memory data register, اللي هو the connection between the CPU and the data register. Then you have your status registers. The status registers, status هي situation الحالة تبعت CPU. The CPU reads the status after each instruction, checks that everything is alright. So the status of the CPU and currently executed program flags where they track الcarry, overflow, power failure, internal computer errors. All of these are done through the flag registers. All of these are done to status registers. We are going to be talking about these later on. Now, register operations, we have different registers, so we have different operations. General purpose registers, they can be used to store values from other locations. They can be used for addition and subtraction. They can be used by shift and rotate. They can be used to test the contents for conditions such as 0 or positive. كل هاد, all of this depends on the type of instruction that we are doing. Okay, all of these depend on the type of instruction that we are doing. So for some instructions, we do move from memory to register or from register to register. Other instructions, we do addition and subtraction. We can say add, like here, we can say move A to BX, where BX is a register. Addition and subtraction, we can say add AX, BX. Shift and store, we can say shift lift AX 3 times. Test the contents, we can say just move AX to AX. This means just pass the register from the ALU and we will read the status. Had a move, we took it already, which was the transfer. Inside the ALU, when we designed the ALU, there was one instruction which was transfer. So the transfer is basically used for testing the conditions of 0 or positive for registers. So operation of memory, each memory location has a unique address. The address from the instruction is copied to the memory address register, which finds the location in memory. The CPU determines if it is a store or retrieval. The transfer takes place between the memory data register and memory. The memory data register is a two-way register. اللي بيصير, you have your CPU, you have your memory. Between the CPU and the memory, we have the address bus, and we have the data bus. Now, the address bus is unidirectional. والداتا باس is bi-directional، يعني هذا بروح في اتجاه واحد، الادرس بس من السي بي يو للميموري، بس الداتا ممكن من الميموري للسي بي يو او من السي بي يو للميموري. السي بي يو عشان يتفاهم مع الميموري من خلال الادرس باس، first it puts the information in something called the memory address register. So the address from the instruction is copied to the memory address register, which finds the location inside the memory. So memory address register بيقرأ من السي بي يو وبيحط المعلومة على الادرس باس. Once we get the information, we are going to read it through the memory data register. هذا الميموري داتا ريجستر بيقرأ، السي بي يو بده يكتب في الميموري، بحط الميموري داتا ريجستر، او السي بي يو بده يقرأ من الميموري، بيقرأ من الميموري داتا ريجستر. فالميموري داتا ريجستر is basically a two-way register. ايش يعني two-way؟ يعني بامكانه السي بي يو يقرأ منه او يكتب عليه. الميموري ادرس ريجستر السي بي يو فقط بكتب عليه. اوكي، تذكروا الادرس باس is unidirectional and الداتا باس is a bidirectional bus. So the relationship between the memory address register and memory data register. فالmemory address register من السي بي يو it puts the address over here. This address will go to an address decoder inside the memory itself. بعدين let's say the bit which was selected is this individual bit. Since this one is selected, the values will appear on the memory data register inside the CPU. This is your data bus. And this is your address bus. This one, this part over here is your address bus. So assume that on the address bus, we have the value, which is this one. This is the most significant bit, and this is MSB, most significant bit. ايش يعني most significant bit؟ ايش يعني most significant bit؟ اكثر بت لها اهميه، يعني هذا الرقم لما تيجي تكتبه راح تكتب لي اياه 110001. هاي least significant bit، فهاي least significant bit بتيجي هون، والmost significant bit بتيجي هون. فهمتوا؟ الموست significant bit اللي هي اعلى رقم على الشمال، الليست significant bit اقل رقم على اليمين. فلما انت تيجي تعمل الفاليو للادرس راح يطلع معك 11301 اللي هو 49 in decimal. فالادرس ديكودر will activate line 49 and whatever is on line 49 will be appearing in the or on the memory data register. فبالنسبة للميموري داتا ريجستر، مجرد ما الخط or line 49 is active, it will only see this information over here. Now this information over here will be stored in the memory data register, and the CPU will read from the memory data registers. all other cells, all other memory locations will be deactivated. تعرفوا الديكودر right? You know the decoder?
ايوه دكتور.
طيب اعطيني سايز اكزامبل على سايز للديكودر.
3 by 8.
3 by 8 or 2 by 4 or ببساطة n multiplied by 2 to the power n. مثلا 2 by 4 if I have A1 A0, so we have 0 1 0 1 0 0 1 1, and we will have I3 I2 I1 and I0. Your outputs will be 1 0 0 0 0 1 0 0 0 0 1 1. Sorry. So here will be 1 0 and finally 0 0 0 1. فالديكودر will activate one line. So when you put an address, in this case, when you put this address, all the other lines will be zeros and only this line will be activated. ليش 49؟ لأنه الأدرس corresponds to 94. Here you can see that this address corresponds to 2. This address corresponds to 3. And so on. فالميموري الادرس decoder will decode the addresses from the address register and it will pass the information to the decoder. The decoder بفعل only one memory location. Once that memory location is activated, then basically what happens is you are going to get your data. The individual memory cells, each memory cell will hold 1 bit. So if the address line is 1 and the line is active, read is active, so all of this is AND, so this one is high. So whatever is here will be going through over here. Now if we want to write, the address line is 1 and the active line is 1 and the write is 1, so we are going to write in this way. So basically this is just an illustration توضيح كيف بنقرأ وبنكتب من memory cells. How do we read and write from the memory cells? This is basically just an illustration to how things are done. So you want fast. You want the registers because they are fast. Is it possible to build your computer which uses only static RAM? Because the RAMs are fast. This would be very fast. And in this case, we will not need cache. So this would be very expensive. Now, in terms of speed, okay, in terms of speed in a computer system, when we talk about computer systems and speed, RAM is fast, but RAM is compared to the CPU is not very fast. It is a little bit slower than the CPU registers. فهذا CPU registers making a problem. So can we create only the computer with using RAM? This will be very costly. So in the next part, in the next class, we'll be talking about the cache memory, and we will be discussing how cache memory will operate and what is cache memory. Okay, so do you have any questions on this part? On the registers, do you have any questions?
دكتور هذا الويك بيكون داخل في
بس فقط لعند الريجسترز، الجزء اللي اعطيتكم اياه هسه الصبح، اول 13 سلايد. اوكي. المحاضرة is recorded. I am recording it on my computer. I will upload it on SULMS, so it will be clear. Okay, المحاضرة is recorded. The lecture is recorded, but it is recorded on SULMS. The reason, again, once more, it will be more clearer for you when you want to attend it. Anyone has any more questions? Okay, so I will stop the recording here.